All right, we seem to be recording. Let's go ahead and get started. Today's lecture is a little tricky in terms of what we're going to do with audiovisual. I hope it all works out. I guess we'll find out. First I can point out the answer to our survey question last time. It's a very interesting image that different people see different things, and it's almost evenly split. That was kind of a cool question to have. I did want to remind you or point out to you something that's new, as of Wednesday. So under the Zoom links, remember this is where I'm trying to collect together all of our different various links, and I've added a new table at the bottom that has the TA's office hours and their Zoom links for office hours. So that's there, it's on the Zoom links page. I also do mention up here that these are their official hours, but all of our TAs, you could ask them to arrange a meeting outside of these hours if it doesn't work for you. So they all do a by appointment kind of thing if that's necessary. Okay, we've got some new material I want to talk about today. I wanted to begin, though, I'm going to use a good chunk of the lecture to talk about this example from last time and to talk about some issues that you have to be thinking about in this homework 4. There's a phrase that we use in the assignment write-up that I think students get very confused by, and I want to make sure that I can explain it to you somewhat better. So this was the BMI, the final program that we ended up with, that the main was very short. We give an intro, we set up a console scanner, and then twice we call a get BMI method to give a value to a variable in main. We report the results for those, and then various other methods that those call. In the chapter, after this case study, I mentioned it's done in detail in the chapter 4. So it's a great thing to read through to understand. And after the final version is shown, this final version of the BMI program, there's a section in there on procedural design heuristics, kind of things that you should be thinking about as you're designing how to create a program like this. I've mentioned that the use of static methods is something that we would call procedural style programming, kind of command-oriented programming. And we use the word decomposition when we're talking about the choices that you've made for how to decompose, how to break down the program into methods, and how those methods relate to each other. So there is this section at the end of the chapter that talks about kind of what would lead to a good decomposition, what's not so good, what are some of the things to be thinking about. And it includes a program called bad BMI. So this is from chapter, it's in chapter 4, but I wanted to spend a little bit of time talking about it as well. So this is an example, a version of the program that it's only dealing with one person's worth of information, but it does a bit of intro in main, and then it calls a method called person, passing it the console scanner. That method reads in the height and calls a method called getWeight, passing in the console scanner and the height. And then that method prompts for the weight and calls a method called reportStatus, passing in all three variables, the console, the height, and the weight. And then this is kind of that final method that we have there. What I want to do is to try switching to the document camera. So I hope this is going to work out for me. So I want to draw actually it would work better if I tell it to send that to the projector. So I'm going to send that to the projector so that I hope then that the recording will pick that up. So there's a concept that's mentioned in this section, and it's also mentioned in the assignment write-up, that you have to avoid what we call chaining. So I want to talk about chaining in particular, because this is something that I think people find very confusing. And the bad BMI program, I think, gives me a good opportunity to talk about what's going on. It's hard to draw great pictures of these things because the picture is very static. It doesn't change. A program's execution methods are calling methods and returning things and so forth. So there's a lot that goes on in a program that's hard to capture in a drawing. But I can at least capture a little bit of what's going on. So there's a method main that introduces a variable called console, and it calls a method that's known as person. Not a great name for a method, but what can you say? So there's a method called person, and it is passed the console scanner. So main passes its console scanner into something that's also known as console inside of the person method. So that's passed down as a parameter. And then person method introduces a variable called height. So it has a local variable called height that it introduces. So that's the first time we've seen that variable. Then it calls a method. Let me make a kind of a wide box here to be able to have enough room for this. It calls a method that's known as getWeight. Why this one is getWeight and that one is person, I don't quite know, because that one gets the height, but it's not called getHeight. But in any event, this is a bad BMI. It's meant to be kind of a bad program. And what does it do? It passes the console scanner and the height as parameters into this method. So this method knows about the console scanner and the height because they're passed as parameters. And it introduces its own variable called weight, which is a local variable that's introduced there in that getWeight method. Then what happens? It calls a method called reportStatus. And the reportStatus method is passed the console scanner, the height, and the weight. It's passed all three of these things as parameters. So all three of these are passed into the method to things with the same name. Console and height and weight are passed in as parameters. And it has an extra local variable called BMI that it uses to compute the BMI. So that's finally when we get, once we've got both the height and the weight, using the console scanner to obtain it, we compute a BMI, and then it reports the results for that specific student. So this is the bad BMI program. One of the things that I'm going to point out, because since I'm using the pad here, you kind of have the option when you're using a piece of paper like this to be using it in what we would call portrait mode versus landscape mode. And I think, and so you're going to see that when I get to doing the good version of the BMI program, I'm going to do it in landscape mode. And that itself should be a kind of an indication that there's something that's not very good going on here, that it's kind of in this up and down column, that there's not branching out going on. It's not broad, it's deep. So that should be kind of an indicator right away that maybe this that's not a very good thing that's going on here. There's a much more important clue that I want you to pay attention to, which is that there are no returns. This version of the program has no methods that return anything. All of the information flow, remember that, and this is really what this is about, is kind of information flow, and what would be good information flow, what would be a good decomposition that has good information flow versus not very good information flow. And here, all of the information flow is down, down, down. We just pass it down, pass it down, pass it down. So that should be a red flag to you, that if you had something that had no returns to it, that's problematic. I'm going to switch back to the computer in a second, but let me mention that one of the confusions that people have about the idea of chaining is that they get the impression that you shouldn't have main calling a method which calls a method, and maybe that one calls a method, that's what chaining is. And that's not so. It's okay to have main call a method. It's okay for that method to call a method. It's okay even for that method to call a method. So having methods call methods is not what makes this chaining. It's something else that makes it chaining. It's kind of the one-way information flow. all of it flowing downward and nothing coming back up. That's what makes this chaining. Well, let me see. Let me go back to the computer for a little bit. And I wanted to begin by pointing out a particular thing that's going on with this report status method. So it's being passed the console scanner, the height, and the weight. By the way, this is an example here of where I had a line that was going to be too long, and so I broke it across 2 lines. And you can indent by 8 spaces. That's one of the rules that people use for this, the part of the line that goes on this second line of the file. But another common thing is to kind of line things up relative to these parentheses. That's another common way that people will deal with long lists of parameters like this. So it computes a BMI using the variables height and width, and then it prints various things out. So there's a style issue with this method, and the style issue has nothing to do with chaining. It's a different style issue. So I'm giving, try to think about it for a second. I'm being passed these 3 parameters. You can see what I'm doing in the method. What's the error here? And it is an error that would lose you a point. It's something that we do take off points for if you make this particular style error. And I don't know if you saw the error that's here, but I'll mention we're passing in the console scanner. It's almost like in writing this program, you're like, well, I always pass the scanner. Scanner. I always pass it into a method. But do you see the console scanner being used anywhere in this method? I don't. And it's not used by anything that this method calls. So the console scanner never appears anywhere inside of the method. So there's no reason to pass it as a parameter. So that's an extraneous parameter. That's an unused parameter. And that would be a style error from our point of view. So that's a mistake that this thing is making. That's not very good. Let me switch back over to the document camera and let me talk a little bit more about the chaining idea. So one of the errors we'd say here is that we shouldn't have passed that console scanner in. So, if we were wanting to make it better, we would have just been passing in the height and the weight. But there's much bigger problems here. This program was kind of a version of the program that was dealing with one person. And it kind of does the right thing for the one person. It prompts for their height in here. It prompts for their weight in here. It computes a BMI here that it then reports. How do you change the program so that it does it for 2 people? So how can you kind of do the version of the program where it's going to manipulate 2 different people? Because in that version of the program, you have to get the height and the weight of the first person and compute a BMI, get the height and the weight of a second person and compute a BMI. So it's kind of, you get the height and weight, do a computation, you get the height and weight and do a computation, and then you report the information for the first person, and then you report the information for the second person. So here, what you could do is from main, you could call this person method twice, but then what it would do is it would get the height and the weight and report the results of person 1. And then when you called it a second time, it would get the height and the weight and report the results for person 2. But that's not the order. That's not the way we want it to be done. We want to get the height and weight for both, then report results for both. So this program, this version, is very hard to pull apart to get it to do that kind of, a variation of what we were looking at. So normally I'd be asking people for suggestions here. There's a lot of thoughts that people have about what you might do. The idea that I think ends up having the most promise is, well, look, if you got a height and a weight and you used it to compute a BMI, then somehow that BMI that's way down here, trapped in this low-level method, it has to come back up the chain. It has to kind of come back up this sequence of methods, and that's what we use a return for. That's what we use returns for, is to get a value to go back. But even here, if you think about it, it's pretty inconvenient in that BMI would have to be passed back here, which have to be passed back here, which would have to be passed back here. But at least it's better than what we're doing here. But we'd want to then not be doing the report status down here. That has to be done at a later time. So what you'd want to kind of do is to break off, that method, to break off the report status so that it could be called later. So this is where we want kind of the breadth to it. We want the branching type thing where I'm going to be executing one branch that gets me a BMI value, and then I can do that twice to get 2 BMI values, and then I can go into another branch that does the reporting. And that means that main is going to need to store that information. So that's kind of another indicator here that this is chaining, is that main is not storing anything interesting other than the console scanner. So that's not good. That's a bad sign. So the key issue to be thinking about with chaining is calling a sequence of methods that never return anything back up the chain. That's chaining. Is kind of calling something where you pass values down, 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 and you never return something back up the chain that would then be used in some other branch of the program. That's the key difference. Well, let me draw a diagram for you for the get BMI version of the program. And again, this is hard to draw a very good diagram. It's hard to capture all of the dynamic nature of what we're doing here, but let me give it a try. So we've got a main method here that introduced 3 different variables. It introduced console, it introduced BMI1, and it introduced BMI2. So it had 3 different variables that we used here. And what we did here is we basically ended up calling a method. There was a method that we made that was called getBMI. And we passed in the console scanner. So that got passed into the getBMI method. Console was passed into getBMI. And getBMI had variables for height, weight, and BMI. So it introduced local variables for the height and the weight and the BMI. That's what we did inside of this method here. And it returned something. So basically the BMI value here got returned back to this method here. It's hard to kind of show it very well because basically this method got called twice. So we passed in the console scanner, it used it, it set up local variables called height and weight, used it to compute a BMI. That BMI was passed back and stored in BMI1. So that was one call. And then we did it again, we set up a height and a weight, we computed a BMI, and that got passed back to BMI2. So it's hard for me to show the 2 calls, to kind of show the dynamic nature of that. But returning the BMI here ended up allowing me to set these variables called BMI1 here and BMI2 here. We also had a method that I kind of split off from main called giveIntro that just had the printlns that introduced the program. And it turned out that giveIntro was so simple that giveIntro had no methods, no local variables, and it didn't need any parameters. So there was no information flow for giveIntro. There was nothing going in, nothing coming back. The getBMI was much more interesting because something was coming in and something was coming back out. You may not remember this, but I introduced a method here that basically there was this BMI formula. So I made something called BMI4. I introduced a method that would compute the BMI, that would have the formula for doing the BMI. And what I did is I passed in the height and the weight were passed in as parameters here. So there was a height and a weight here. And then this one had a formula. It had a return that had a formula that returned that value, and it got stored in that BMI variable there. So height and weight got passed into the method, and then a formula was used to compute the BMI that assigned a value to this variable back here. And notice how there's kind of a middleman thing here. This method returns a thing that set this variable here, and then this variable got returned, which set a variable up there. So that's certainly a possibility here, is that, values can flow down, values can flow back up again, and this is kind of something where it flowed twice. It flowed from the lower level method into this variable called BMI, which in turn was used to set BMI1 or BMI2. There was also a method that I introduced here called report results. So let me kind of introduce this. Report results. And what I did for report results is that I passed in, again, I was kind of over here, I was showing what I was passing in this call. Here, I don't have a place to, I don't have kind of a second place to show what I'm doing. But BMI1 and BMI2 were passed as parameters into this method here. So I kind of passed in BMI1 and BMI2 as parameters into this method here. So that was another bit of information flow that I had. This method had returned values back to the BMI1 and the BMI2, which in turn got passed over to here. Again, kind of this breadth idea here. And then this one called two different methods. There was a method called report status. And report status was passed basically we called it once passing at BMI1 and once passing at BMI2, and then inside of the method I referred to it as BMI. So there were two calls here, one with BMI1 being passed into BMI, one with BMI2 being passed into BMI. So I called kind of a report status method. This was the nested if-else that kind of reported, underweight, average, and so forth. So that was this little method. There was also a method that I introduced here called round one, rounds to one digit, and it had a parameter called n. And what I did here is, again, it was BMI1 and BMI2 that I passed into that variable. I can't read my handwriting there, but that's supposed to be an n. But we passed in BMI1 and BMI2, and we passed back a value that was kind of the rounded version of that number that was used by this method to do the printing. So again, the diagram is not the greatest because it's hard to show all of what's going on here. But the idea is that we have information flowing down into methods. So having a method call a method call a method is not bad. Or even just the idea of passing values down is not bad. But this one has values coming back up, being stored in variables in main, and then those same values being passed on to a different method later, a branching method. So there's kind of this thing where we're kind of getting the values for a person, get one person's BMI, get another person's BMI, and later pass those values on to this thing that does the reporting. And an interesting thing about that is that there's this get BMI branch of the program that knows nothing about report results. And there's this report results part of the program that knows nothing about get BMI, which is the way you want it to be. You want to be able to kind of break down your program into these different bits of code, where this is dealing with the prompting and the reading and the computing, and this is dealing with the rounding and the printing and the figuring out the if-else to figure out what kind of what kind of adjective to use for describing the person. So this is kind of the nicer version of it, with a give intro that's completely separate from all of those things. Again, the kind of the breadth aspect to it. That's what makes this a good program, good decomposition. Okay to have methods call methods, okay to have values passed down, but we want to be returning values back up to main, values that are used in separate branches, that are used to go in some other direction later on. That's the thing that you're looking for that tells you that you're not doing chaining. Okay, Unfortunately, I don't have the opportunity to be able to ask you what questions you might have. This is something that you could ask TAs about in section or in office hours. They might, if you wanted to make sure that you understood whether something was chaining or understand why something is being interpreted as chaining. Okay, so I will put up the BMI2 was on Wednesday's calendar. The bad BMI I'll put up on today's calendar in case you wanted to take a look at that. All right, well, the next thing that I want to talk about is today we're supposed to talk about strings and characters. So I want to talk about that for a bit. I have a program here called Say Cheese. I think I have mentioned at least once the idea that you can have variables of type string. So this is a very simple program. What I'm doing in here is I'm setting up a variable expected that refers to the string cheese. So string is a type, and notice capital S, so that means that it's the name of a class. And so what that means is that they're objects. Strings are objects. And in today's lecture, we're going to understand that better. We haven't really been treating them that way. We've been treating them more like simple things, but we're going to see some examples of how you have to understand that strings are objects. So I set a variable to cheese, quote cheese, unquote, and for the other variable, I use the console scanner to make a call on next. And then I see whether the two are equal to each other. I said to say cheese. If you say it, I say thank you. And otherwise, I say, oops, you said something else. So, if I compile and run this version of the program, I think you understand that, if I say milk, that's not cheese. So you're going to say, oops, you said milk. That wasn't what I was looking for. And I think you also probably understand that if I say cheese with a capital C, for example, that's not the same. It's similar, but it's not the same as cheese when all of the letters are lowercase letters. So that says, oops, you said cheese. Okay, well then let's be nice and do what we're told. We'll say cheese. And so I'll hit enter. Oops, you said cheese. It was supposed to say thank you, because I did what it asked. Apparently this is a program that can never be satisfied. No matter what I give it, it's not going to be happy. Well, I want to understand this, and it turns out that to kind of understand what's going on here, we have to understand the idea that there are primitive types. So the primitive types are things like int and double. You can always tell it's a primitive type because it starts with a lowercase letter. And then there are object types, and they work in different ways. So things like string with a capital S is an object type. So is drawing panel, so is graphics, so is color. All these things that have capital letters. These are the names of classes, and those are these object types. And objects have different rules than primitives. This is an annoying aspect of Java, that you have to kind of know two sets of rules. But hey, we're using a real programming language. Java was not designed for novices, but the nice thing is that people actually get paid to program in Java. You're learning a real, practical programming language. In any event, let me come here and set a stop on this line of code. So let me compile, and I'm going to debug this time. And let's stretch this out a little bit, and so we can see what's going on here. So maybe I'll even look at a little bit more of this. So I'm going to execute that first line of code, and you see that it's set up a thing called expected. I like what JGrasp is doing here, by the way. I like the way that it's the picture that it's drawing. I think I've mentioned that the guy who does JGrasp, James Cross, really likes my co-author and me. So he looks at our pictures and he tries to make things match. I think this is a nice way of thinking of it. We're going to talk more about this idea that this variable is storing a reference. That's why we draw an arrow. There's a reference to a thing that stores cheese, that stores the text of cheese. Well, I'm going to let it execute this next line of code. And when I do that next line of code, let's go ahead and go. Oops, I think that what's going on is it prompted, it's waiting for me to type cheese. So I'm going to type cheese like I did before and hit enter. So now it's set up a second variable. So you can see there's this variable called expected and this variable called response. And then it sees whether response is equal to expected. Well, let me tell you what's going on here. So basically, I have two different objects, both of which store the same sequence of characters. So I have two different objects that are storing CHEESE. You could think of it as being like, suppose you're buying textbooks. You go to the store, or the bookstore, and there's a whole bunch of textbooks. You see a big, huge stack of textbooks. You could imagine taking two books off the stack, and if I asked you, are those two books equal to each other? Well, what do you mean by equal to each other? I mean, they're in the same state, we would hope. We hope that, neither of them is damaged or anything. They look exactly alike. They've got the same stuff inside of them. They're equivalent, but they aren't the same book. I mean, if you grabbed one of those books and I grabbed the other one, and I wrote something in the margins of my book, it doesn't appear in the margins of your book. They're two different objects that happen to be equivalent, would be the right way of thinking of it. And that's what's going on here, is that we have two different objects that store the same information, but are equivalent, so that in the sense that they store the same sequence of characters. JGrasp gives us a little clue to this in that it has this little notation here. This is a JGrasp thing. This is not something that Java says to do, but it numbers the objects that it deals with in this program. And it's showing us that that's object 454, and it's showing us that that's object 459. So those are two different objects. That's what it's letting us know. And when you do an equals comparison, when you see whether this is equal to this, what you are asking is, are these exactly the same object? Are they one and the same? One object involved? And the answer is no, and that's why it went to the else part where it's going to say, oops, you said cheese. So we need something different than what we're doing here. So let me go ahead and we can go ahead and end this. What we want to do instead is we want to use a method of the string class. So, we've been seeing, drawing panel, we've seen that it has various methods like, set background, for example, is something that we do with a drawing panel. So you use the dot notation and then a call on a method when you want to do that. Well, strings have methods too, and it has a method called equals, response.equals. And so I can kind of make a little test here where what I'm doing is asking the response string. I'm kind of saying to the response string, hey, response string, I want you to do an equals comparison for me, and I want you to compare yourself against your fellow string expected. I want you to see whether you are equivalent. And then that comparison is going to do what we wanted it to do, which is it's going to see whether they store the same information. I could equally as well have asked expected whether it dot equals response. So it should work in either direction. That's a requirement of the equals method, that it's supposed to be symmetric in that way, to give the same answer. So if I compile and run it now, and if I say cheese, now it says thank you. But then it still would not if I typed in something other than cheese. As usual, there's a slide for this, and I believe that's this one right here. Not that one, this one. So there are methods for testing strings. Equals is one of those methods. There's several others that you might want to know about. So those are in the notes for today. Things that you can ask one string to do some kind of a comparison with another. So here, what it starts with, it's seeing whether it begins with those characters and it ignores the other ones that are there. Okay. What I want to do next is spend a little bit of time talking about other string methods. So let me go into the interactions pane, and let me set up a string S, which I'm going to set to be hello there. So I've got a string variable S, which is hello there. I'm going to click on this S box, and I'm going to drag it with my mouse and move over to the code window and let go. And JGrasp sets up something here for me, which is a way to view this thing. And there's different choices you can make with this viewer. So for example, the thing that I want to do here is something known as char array. I want to see the individual characters of this string. So it's showing me what this S looks like. It's got the characters HELLO space THERE. And I want to use this as a way of understanding another table that's in the slides for today that shows a bunch of string methods. So JGrasp is, our JGrasp window is kind of covering up some of what's there. We'll take a quick look here. So there's various methods that the string class has: length, substring, to lowercase, to uppercase. Let's take a look at some of those methods. We'll go back into JGrasp over here. So what's going to be the length of this string? You might think 10, because that goes up to index 10. But one of the things in Java is that strings and other structures like it are indexed starting at 0. So the first character is at index 0. So there's actually one more character than that. So if I say to S, hey S, what's your length? It actually has 11 characters. If we wanted to get a substring, so suppose I wanted to get the characters ELL. What are the indexes? That's 1 through 3. So you might think that I would say, give me the substring of 1 through 3. Give me those characters. And I get an EL. I don't get ELL. I only get one of the L's, not both of the L's. Well, why is that happening? If you read the description of the substring here, index 1, index 2, the characters in this string from index 1 inclusive to index 2 exclusive. So remember that the first index is included, the second index is supposed to be one beyond what you're looking for. So if you really wanted the substring from 1 to 3, you're supposed to use an index 1 higher. You're supposed to give it index 4 to say, I want everything up to, but not including index 4. So we'd have to use an index that's 1 higher in order to get the 3 characters ELL. Seems like a weird convention, but it's actually a very common convention. It's used by a lot of programming languages, including Python. The explanation that I've heard for it is that the reason that second parameter is a 4 is you kind of think to yourself, well, the starting index is 1, and I'm looking to get 3 characters. So the way to think of the 4 is that it's the starting index of 1 plus 3 characters. That's a way of knowing that it's a 1, 4. Gets you the ELL. Well, what if I wanted to pull out the word there? How would I do that? So I could do s.substring, and where does it begin? It begins at index 6, and what's the final index is index 10, so I think it's not going to work, but I'll do it that way initially, just to show you that it gets me there, not there. It didn't include the E. That's because I have to use an index that's 1 higher than that. So I wanted to use index 11 here. There's an interesting thing about this, which is that there's no character at index 11. Look at that. There's nothing sitting at index 11, but that's the convention. You kind of give the index that's 1 beyond what you were looking for. And you might think, well, I can just give it a really high number, or even, like, what if I just said 12? That's going to be big enough that it'll be beyond the end of the string. Well, Java's very picky about this. It really is supposed to be 1 beyond. So this is 2 beyond, and it says string index out of bounds, that there's no such, no reasonable way of thinking about that index. So it'll let you refer to an index 11, it won't let you refer to an index 12 or higher, and it won't let you refer to negative indexes. So it's, the 11 is a kind of a weird special case. But there's another thing you might have noticed here, which is that substring has a variation where you give it just 1 index, and as it says, if index 2 is omitted, it grabs till the end of the string. So if I had just kind of said, give me s.substring starting at 6, it just gives me everything from there to the end of the string. So that's kind of the easiest way to do that. All right, let me show you one last thing, which is that I can ask for, there's a method that was mentioned on the slide here, to lowercase and to uppercase are other methods. So I could say to uppercase. So I can ask a string to make an uppercase version of itself, and there's hello there, we're all in uppercase letters. If I ask the interactions pane, hey, what's S equal to now? So I'm just going to hit enter, so it tells me what S is. S is unchanged. So S is still kind of the lowercase version of the string that we had before. So, and that's mentioned in the description. It returns a new string. So uppercase, lowercase, they don't change the string, they return a new string. So if you really did want to reset S so that it was that uppercase version, you'd have to do an assignment. You'd have to say the variable S is going to be reassigned to the new string that's being returned by S.to uppercase. And watch what happens right up here. S right now is object 184 that refers to the hello there. And you can watch what happens as I hit the enter key. And it put it in red to kind of let you know, oh, it's a new object. It's object 209, and it's got the uppercase characters. So I really did reassign the variable so that the arrow is pointing somewhere else now. It's referring to a different string, a string that's the uppercase version of that other string. There is another thing that, well, I think actually I'm just going to kind of skip this other thing that we haven't talked about the idea. There's a type that's known as CHAR. Some people pronounce that as char. I think that's wrong. I pronounce it as care. You know, this is one of these things, if you got a bunch of programmers in a room, you'd find half of them say one and half say the other, and they might fight each other over it if you let them. You know, so you can pronounce it however you want. You can see what your TA does. I call it type care. You're probably not going to have to manipulate characters in the program, so I'm not going to say a lot about type care. It's a primitive type. Notice that it starts with a lowercase letter, we use the double quotation mark, you know, to do a string like hello there. For character types, we use an apostrophe, like quote A, unquote, and they can only be one single character. So this type that's known as care. But as I said, you don't have to you're going to be doing string manipulations. So you'll see in an example I'm going to show you that I'm going to do a little something with type care, but you don't have to be understanding all the details of that. That's something that you'd get to more. I mean, I think the 143 has some assignments where you have to manipulate things as individual characters. All right. Well, I wanted to spend the last bit of time going over an example for you that it's a little bit more complicated than what we've done, and I don't expect you to understand all of the code that we're going to write. We also only have 8 minutes to discuss it, so we're not going to be able to do it in great detail. But it's kind of a fun little example that I thought you might find interesting. So the idea is that suppose there's some credit card number. So I have a credit card number there. What I want to do is to write a method where you would give it all of the digits of the credit card other than the last one, and it will tell you what the last digit is. It turns out that there's an algorithm for this. This is something that the credit card companies set up so that they could try to detect bad credit card numbers. And it's very helpful to people who are doing data entry. If you're typing in a credit card number, you know, you might type it wrong, so you'd like to get a warning that you made a mistake. And so that final digit of the credit card number is something that we would refer to as a checksum digit. It's a special number that kind of lets you know information about the other numbers. So basically the leading digits are used to compute that final digit, and so that way we can check to see whether if it was a legal number. So let me tell you how this thing works. So I've kind of put the digits here, but I didn't include the last one, the 6. You know, this algorithm ends up kind of alternating between a multiplier of 1 and a multiplier of 2, and it starts on the right-hand side, which is a little bit odd, but that's how it works. I think they were trying to make this something that wasn't that easy to figure out. 2, 1, 2. So then what we do is we kind of multiply each digit by that multiplier. So 4 times 2 gives me an 8. 3 times 1 is 3, 2 times 8 is 16, 8 times 1 is 8, 2 times 5 is 10, 7 times 1 is 7. You know, I hope it's obvious that I'm kind of, you know, multiplying down here. 5 times 2 is 10, 1 times 1 is 1, 1 times 2 is 2, 0 times 1 is 0, 7 times 2 is 14, that's a 0, that's a 14, that's a 1, that's a 14. So I get a bunch of digits. So you do that, you kind of compute that thing out, and then you find the sum of all of these digits. So you add up all of these digits. But in adding it up, I'm not going to add in 16. What I'm going to add in is a 1 and a 6. So I kind of want to add the individual digits of that number. So I get 8 and 3 is 11, and then I add in the 1, and I'd get a 12, and I add in the 6, and that would give me an 18, 26, 27, and another 7 gives me 34, 35, 36, 38, 39, 43, 44, 47, 48. I think I made a mistake here. Just a second. Let me make sure. I think I added something up wrong along the way. Let me start again. 11, 12, 18, 26, 27, 34, 35, 36, 38, 39, 43, 44, and 4 gives me 48, 49, 50, and the 4 gives me 54. Well, let me tell you something about credit card numbers. When you do this little computation, the numbers that you get, the sum of all those digits that you get, adds up to a multiple of 10. So that's the checksum, is that it adds up to a multiple of 10. So, here, multiple of 10, right? Well, it doesn't add up to a multiple of 10, but that's because I didn't include the final digit. So the final digit was a 6. So it really does add up to a multiple of 10. So if I knew that the sum of these things without the last digit was 54, then I'd be able to figure out that the last digit would be a 6. And that's what this method is kind of doing, is that it's computing the last digit, for a number. You might find it interesting that I wanted to have a sample credit card number for this. When I have students in the class, I say, please, someone tell me your credit card number. People are not usually willing to give me their credit card number. But there was an interesting thing that I found on the web where someone on I think it was on eBay, they wanted to prove to someone that they had actually paid for this very expensive watch. So they included a copy of their receipt. The problem is the receipt had their credit card number on it. So this is in the olden days before, nowadays the retailers don't show the full credit card number like this. They tend to show you only the last 4 digits or something of the credit card number. But so that's how, and this is a real credit card number that I'm using that I got from this person who was silly enough to kind of put that on their webpage. So, we only have a few minutes. So basically, if we had more time, I would develop this slowly with you. We would do a cumulative sum in order to add up all these different digits here. And then we'd kind of have to figure out how to turn that into something that returns the final digit. I'm going to make a copy of this here. You guys, if you're interested, you can download this program. I'll put the complete program on the calendar for today. You could try this with your family if you're interested, your parents or something. Say, give me your credit card number, but don't give me the last digit. Give me everything but the last digit. And then you can run this little program where kind of everything but the last digit, and it goes through and does this computation. So let's just kind of take a quick look at what it's doing. It's doing a cumulative sum. And it has a for loop here. The for loop has to go through the digits backwards, because that's how that algorithm works. It has to go from the end of the credit card number back to the front. So that's why we have a loop that's doing a minus minus for the indexes. There's something here that, this is not, it's not really important that you understand quite what's happening here, but this is using a method known as char at that pulls a character out of the string, and then it turns that into its numerical value. Like if it was the character 8, it would give you 8, the digit 8. And so, this is just pulling the individual digits out of the credit card number. We multiplied the digit by the multiplier, and remember that if it was something like 14, you don't want to add in 14, you want to add in 1 and 4. So this is another place where mod by 10 and divide by 10 is helpful to get us 1 and 4 if it was a 14. We have to change the multiplier each time, switch between a 1 and a 2 as we're going through. And in the very end, what we can do is we can take sum and mod it by 10. So like our 54, when we mod it by 10, would give us a 4. Well, where does the 6 come from? It's 10 minus that. So 10 minus a 4 would give us the 6 that we're looking for. But sometimes, mod gives us a 0, and we get 10 minus 0, which would be a 10. So that would be a case where we got to mod by 10 one extra time to get a 0. So I'll just show you an execution of this program. So we'll go ahead and, yes, we'll end the interactions pane and run this program. I think it's telling me that I need to recompile. So let's go ahead and do that. Compile and run. And so I'm going to use that credit card number without the last digit. So I'm getting rid of the last digit there, for that credit card number. And it says the last digit should be 6. This is an algorithm known as the Loon algorithm, if you're interested. It's mentioned in the comments for the program. Okay, that's it for today. We'll do more next time.